Hey guys, so this is, well, as you can see the title, exponential functions, tables, scenarios, graphs, and equations. So basically you're gonna have to, and you've seen basically all these before, you're gonna have to represent an exponential function, or it could be linear, but this one's all exponential, as a table, as a scenario, as a graph, and as an equation. So 1, 2, 3, 4 different representations for an exponential function. And you're only going to be given one. So you'll be given one of these four ways to represent an exponential function, and you'll be asked to fill in the other three. So I'm going to go through this. So let's see. A ball rebounds 80% of its original height. It is dropped from an initial height of 500. You measure and record the rebound height for each consecutive bounce. So you could do different things first here. So I'm going to start with the fact that it's initially dropped from 500 feet. Your initial value is where the input is 0, so that's 500, and it's rebounding to 80% of its original height. As mentioned in the previous assignment, anytime something is changing by a percent, it is being multiplied. Therefore, this is definitely exponential. 500 times 0.8, that's going to be 400, then times 0.8, again 0.8, remember, 80% is 0.8, so you may have to do a little homework on how to change a percent to a decimal to make sure that makes sense. And then 400 times 0.8, again, 4 times 8 is 32, so 320 centimeters. 320 times 0.8, use a calculator as needed. 320 times 0.8, that's 256 centimeters. 256 times 0.8 is 204.8 centimeters. Guys, the equation, remember, it's exponential. The equation is using the form y equals a times b to the x, where a is the initial value, so a is 500, and b is the rate of change, which is it's being multiplied by 0.8 each time, so 500 times 0.8 to the x power. And then the graph, well, the graph starts out at 500 centimeters, right, and at one bounce it's at 400, the second bounce it's at 320, so not exactly 300, we have 200, 100, so first bounce, second bounce, third bounce, fourth bounce. So at 0 it's at 500, at the first bounce it goes up to 400, the second bounce goes up to about 320, a little above 300, the third bounce is at 256. Remember, this graph's not perfect, but it's, just trying to be as close to accurate as possible without graph paper, without taking too much time. The fourth bounce is at about 204.8, and you can see it's not perfect. It definitely could be shown a little better. Like, this almost looks like it could be linear, but it's definitely not a straight line, and you could argue that it is dropping pretty quickly and looks like it is kind of starting to flatten out. So again, not the greatest graph, but that's one way to show it. So you have your four representations. Again, you have a scenario, and then we use the scenario to fill in the table, the graph, and or should I say the table, the graph, and the equation. This one gives me the equation. Guys, remember, in these equations, the initial value is here. The initial value is 20. Each time, this is the multiplier, it's being multiplied by 0.3. 0.3 times 20 is 6, and then 6 times 0.3 is 1.8, and then 1.8 times 3, or 0.3 is 0.54, 0.54 times 0.3 is 0.162. Okay, again, that was initial value is 20. That's where the input is. Whoops, sorry about that. Kind of say it again. The initial value is, remember, it's y equals a times b to the x power. whatever number is where A is your initial value. So 20 is your initial value. In the table, that goes with 0. This number is your constant multiplier, B, right? So every time I want the next output, I can multiply by 0.3. So I did that. 20 times 0.3 is 6, and then 6 times 0.3 is 1.8. Multiply by 1.3, right? Or sorry, by 0.3, and you continue to see my outputs. I'd need to make up a scenario for this, so I don't know. I guess I can make up whatever. Let's see. I started out with, I don't know, 20 pounds of rice. I don't know why I'm thinking of rice right now. Maybe I'm hungry, but either way, started out with 20 pounds of rice. And only 30% is remaining after each day or something, after each meal. Kind of a weird scenario. Doesn't really make a ton of sense, but either way, it's possible. This is a possible scenario. Started out with 20 pounds of rice, and each day I only have 30% left, so 30% of the previous amount. So this would be days and rice in pounds, right? Here, by the third day, there's only a little over a half a pound left. And then the graph, remember the initial value on the graph is 20 pounds, right? We're talking about pounds of rice. Down here, we're talking about days. 2, 3, 4. Starting out with 20. After one day, I'm only at 6 pounds. After 2 days, 1.8. After 3 days, only a little over half. 4 days, I have less than 1/10 of a pound, and this one's pretty good actually. This one, oh whoops, starting out with 20. This one actually looks pretty good exponentially, so that's nice. So I'm going to leave this video for now, and I'll end up posting the answers after for the next two. Thanks for having a look. I hope it helps.